welcome back to the channel. In this video I will test various power supplies ranging from a simple 12-volt battery to an Yaesu regulated power supply and various switching power supplies including an MFJ and conversions from computer, server and even a portable cooler power supply. I will test the different power supplies by connecting them to the antenna. What? Wait a minute. Are you crazy? No, I'm not crazy. I will use an SDR receiver connected to an active amplify antenna that is fed by a Bias-T adapter. That will be the best possible test for RF noise, having the power traveling over your coax. So first, let me introduce you the power supplies and their specs, and the SDR, the Bias-T adapter, and the power cord that I will be using with the different power supplies, the battery, and so on. Then we will start testing each one of them one by one and seeing the RF interference, if any, in the waterfall of SDR sharp. So first, let's take a look at all the power supplies. So here is the battery. I purchased this battery for portable operations, as you can see here. The next one is a power supply for a cooler. For a 12-volt cooler, I put a buck converter. This one is a computer desktop power supply, an ATX power supply. This one is a HP server power supply that I converted. And the last one, this one here, is a Chinese power supply that is used for LED. This is the Yaesu power supply that I got it last year. This is the MFJ power supply, which this is the latest power supply that I got in an auction. In the front it has an output and has power poles in the back. In here we can see now the RTL-SDR receiver that we're going to be using for testing, with a filter for AM signals right there, and then the coax, and there is the Bias-T adapter, and the power is already connected in there. You see the power cord. We will see all those in more detail in the next shot. Okay, let's go now very quickly over the specifications of each power supply. This is for the battery. The battery is a 12-volt battery, 35 ampere hours. That is a SIL AGM type of battery that is also has a deep cycle. And I use this for portable operations, for POTA, parks on the air activations, and this is going to give us a good baseline of power supply that's supposed to have absolutely no RF noise. So after that, we will go in and try the refrigerator, the portable refrigerator, that power supply that I converted with a back adapter. And this is the output is 12 volt DC, 4.5 amps, but when I measured it was much higher than that. It's just to prevent any issues with anything that I connect. I just put a back reducer. Then the computer, the ATX power supply is a light on power supply. Here it says that the positive 12 volts rail has 19 ampere hour max. So I'm not sure if that is true or not. I never try any huge load on this power supply. The server power supply, the Hewlett-Packard power supply, is 12 volts, 75 ampere power supply at 110 to 120 volts input. So this is the biggest power supply that I have. The Chinese power supply is a 12 volt 30 amps power supply that, like I mentioned before, is used for LEDs or is used for 3D printers. And the MFJ power supply is a 30 amp switching also power supply with power poles connectors on the back. And now I'm gonna switch to the receiver. So to power the antenna, the active antenna receiver, I use this power cord. It has in one end it has the barrel adapter for the Bias-T, and in the other end it has power poles. As you can see, there is a toroid in there that has around 6 turns. This is not gonna do much if there is noise on the power supplies. All right, here you can see the Bias-T adapter. It has the female barrel connector in one end. It has a coaxial going to the left that goes to the amplifier that is outside in the back. In the backyard, and on the coaxial going down on the bottom right corner there is going into the RTL-SDR USB receiver, which we're gonna use for this test. As you can see here in the back, I have running already the receiver. I have already running SDR sharp, and now we're gonna connect and we're gonna do a baseline of the signals. All right, as a baseline, I disconnected any power source from the receiver. As you can see here, there are 1, 2, 3, 4, 5, 6 little signals coming in here, even when the antenna is not on. But this is minimal. You can see there is almost no trace on the waterfall here on SDR sharp. So now I'm gonna connect the battery. All right, now the battery is connected, and you can see now that we are started receiving signals. This is probably the most pure type of power that we can feed this RF amplifier, this active antenna that is outside on my backyard. There is areas in here that has a little bit of noise, like this one here. Here is a little bit of noise. I don't know if you can see it on the video. Here, 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 and here. So those we need to consider that when we try the different power supplies. So this is the cleanest that I can get, and I suspect those areas with noise here, this one here, and here probably are coming from the power supply of my computer. All right, now we have the cooler power supply with the buck converter, and as you can see here, I just put a live image on the video, so you can see every time what are we using. And there is a little bit more noise. You can see it here. All those areas are showing more noise. I don't see any big lines of noise, but one thing that I want to show, if I'm gonna connect a little bit of load into the power supply, and you will see how that impact the waterfall. So I have a 12 volt light. which I connected now. The 12 volt light is on. As you can see here now in the waterfall, you can see now how the overall noise increase in the waterfall. And by the way, this is a type of an incandescent type of bulb, so it's not a LED or anything like that that can create the extra noise, right? So this is a simple lamp. And as you can see, when the power supply is getting loaded, is generating more RF noise, as you can see here on the waterfall. So now in the next test, we're gonna do the same thing with a different power supply. All right. Now we have connected the PC ATX power supply with an adapter. As you can see here in the front, I purchased that adapter for $2, and that allows you to use the same connector that comes with the power supply to get all the outputs, and also give you this switch, which I'm going to turn on now. So you can see the power supply is on. On the screen we can see a little bit of RFI here. Here you see this curve. Those curves are the RFI coming from the power supply as the power supply is stabilizing. Here we can see more, but it's more or less the same as before. Not a lot of noise coming from this computer power supply. And now we're going to put a little bit of load, and we're going to see if when it's loaded, it generates more RF noise. As you can see, this one, I connected the 12 volt lamp in this one, which I have it here. Let me see if I can put it on the camera. This is the lamp I'm using to test. As you can see here, this one doesn't add an extra layer of RFI on the output when it's loaded. Is better than the back converted, but I can see here this is interference from the power supply. You can tell, when it's interference, when it's RFI from the power supply, because it's not that it's rarely a straight line. You see, this is curved from the bottom going up. Here is a little bit curved. It looks like it's when I connected the lamp. Let's see if I unplug the lamp, if that line moves. No, not only moves, you see, it went away, or is this one maybe? I'm not sure. Let me connect the lamp back just to see if it makes any difference. Yeah, it's the same line. You can see the RFI that is here in this part, it moves to this part here when the load is connected. But there are some birdies like this one, which where I have now the cursor, but there is nothing very terrible, right? Is less than 3 kilohertz. This is probably 1.5 or less, the bandwidth of that birdie that I'm showing on the screen, because this whole thing is 3 kilohertz, right? So this is a little bit smaller. All right, enough with the PC, and let's switch to the next one. All right, and now I have on the bench the HP server power supply that I converted to an up the output voltage to 13.22 volts. That's the maximum that I could get before tripping the protection of the power supply. And this is not yet connected to the active antenna, to the SDR, but this is interesting. You can see there are 3 birdies right here on 114, 125, close to 14 to 200, and or no, a little bit 200, 220 and 14360, and this is not even connected to the antenna. But look, when I put my finger on top of the case, the RFI is going away, so it looks like it's missing some grounding or something. So I'm gonna put it to the ground of the station just to see if that helps, and then we're gonna continue testing. All right, this is very interesting. You see, I connected to the. I don't know if in the camera shot we can get. No, we don't see that. But there is a green cable is going on the back there. That is connected to the chassis of the power supply, and that is connected to the ground, to the station ground, and you can see here that reduce the RFI a lot. I never done this type of test before, and this is a very interesting finding. So next, let's connect the antenna to the power supply. So now we have the antenna. Wow. This server power supply has a lot of RFI. You can see there is one here, there is another here, there is another birdie here, there is another one in this section, there is another one here, and those are big ones. Those are like a 3 kilohertz, yeah, bandwidth birdies. So those are big ones. And I didn't put any load. I used this power supply before with my radios, and I didn't notice anything in particular when I was using it. If you tune on one of those birdies, you will not hear anything because this is very strong. So let me put a little bit of load. Yeah, I connected the lamp, and you can see immediately on how the birdies, they all adjust. They move to the right or to the left. The power supply is adapting the internal frequency to the load. As you can see, that is a tell, for the power supplies. The switching power supplies, when you put load, if it's producing interference, that RFI will move, it will switch frequency. All right, so we know that so far this probably is the worst one. Let's move now into the Chinese power supply. That's next. All right, the next one is the Chinese switching power supply, and this one up the voltage has a controller, a regulator in there, to 13.83 volts according to my multimeter. As you can see, hopefully you can see on the screen on the video. I connected also to the station ground just to be fair, and I'm gonna now connect to the. I'm gonna connect now to the antenna. All right, it's now connected. I don't see any huge interference or birdie like the HP server had. That's a very good signal. The power supply has been running for a few minutes now before I connected, so maybe it's stable. And the one thing that we're gonna do again is to connect a load. Oh no, I can see here. I can see here a signal moving on the waterfall, so that is a little bit of RFI. I can see it here too. Let's see now when I connect the load if this persists. The other thing is the good of the difference of doing this instead of doing this testing with your radio is the level of detail that you have in an RTL-SDR waterfall on the signal is much precise. You have more definition in here than on the screen of your radio if your radio has a waterfall. All right, now let me connect the lamp. Okay, lamp connected. In this case, I don't see any variations in or adjustments in the load. And this one I use a lot, this power supply. This one I use many times with my radios, and I didn't notice anything that is preventing me to use the radio. I do notice some RFI here and there, and I recognize the power switching power supply, the RFI audio, so I can tell when it's putting interference or not. The signals are not, the RFI from the power supply is not a stable signal in one point. Most of the time is adapting. I can see here on the waterfall a couple of birdies that are moving. So if you're tuned in a particular frequency and you have RFI from the power supply, most likely that is not going to last too long on that frequency. That's the other thing. So what is next? Next is the Yaesu. This is not switching. The Yaesu is an all power supply is regulated. We're gonna try that one, and we're gonna leave the MFJ for last. Okay, now I hook up the Yaesu FP707 regulated power supply. This one is not switching power supply, so I expect that this is going to have a very clean signal with no RFI interference or noise into the antenna. So let's power on. Let's see what happens. All right. There is nothing that we didn't have before, even when we tested with the battery. As you can see here, these signals, they were already present even when the power supply, they were off. Those are the ones that I mentioned at the beginning when we took the baseline with no power. So this is pretty good. These areas that we have in here with a little bit of noise in here, and in here, they were present even with the battery, and I presume those are coming from somewhere else, maybe my computer power supply, like I mentioned earlier. So there is still the WPX RTTY contest going on today. I think there's a few more minutes left. There is still a lot of activities in this part of the 20-meter band. Anyways, now this is probably the cleanest, the regulated power supply. So now we're going to move into the last one. Last test is going to be the MFJ switching power supply. That is going to be our last one for today. Right, this is our last test. This is for the MFJ switching power supply. So I want to power on the power supply and see how much RFI is putting into the antenna. So it's on, and it seems to be very clean. Honestly, by looking at the waterfall, I cannot tell that that is any interference coming from RFI, from the power supply into this signal, because I have this power supply connected into power pole distribution hub here. I'm gonna turn, instead of connecting lamps, I can turn my radios on, and we will see if there's any interference here, any RFI when the power supply gets loaded. So I power my base VHF, UHF radio, and you can see here is nothing. no birdies, no switching in in the level of noise anywhere on the screen. Is anything detectable as coming from the power supply. So I'm gonna power one more radio just to see if it's with more load is gonna show anything. And now I have two radios on and nothing. Very, very, very clean output. Really, this MFJ seems to be properly filtered for radio usage. All right, that's everything. I hope you like it. If you like the video, please hit the like button. If you want to be alerted when I put new videos, please subscribe and click on the bell so you get notifications every time I upload a new video to the channel. Thanks for watching, and until the next time.